Hey folks, Dr. Tom McNamara here again for our course in trigonometry. In this video we are going to discuss the amplitude and period for the graph of a trigonometric function. So I've got my graphing calculator software set up here. I'm using Desmos, which is a website. You can just go to that on the internet. Let me get out of the way and we'll get to work here. Okay, so I'm going to do something right here. I'm going to do y equals cosine x. Okay, y equals cosine x. So this is our familiar graph of the cosine function. Notice on the x-axis, I've got tick marks every pi over 2 units. Remember, those are kind of our anchor points. So the cosine starts up here at 1, then drops down to the midline, 0, bottoms out at -1, back up to the midline, up to the top, and as you can see, that repeats over and over and over again. Now, I want to show you what happens if we change up the function a little bit. We're not talking about cosine 2x. Ooh, no, that's too many x's. We're not talking about cosine x, we're talking about cosine 2x. Okay. In fact, I'm going to do a little trick here. I'm going to put a B there. Desmos is going to let me add a slider. Okay, B can go from 1 to, let's make it 1 to 5 with a step of 1. Okay, so when B is 1, we're just dealing with the function cosine x. And we go through a complete cycle in 2 pi units. Okay, remember that's the period of the cosine function. So the period and the length of one complete cycle, same idea, same thing. Now, let's look at what happens when we change the value of b. We're going to slide this. We're going to look at b equals 2. Now I want you to notice, by the time we get to 2 pi, we've gone through 1, 2 complete cycles. Okay, in other words, the period, the length that we need to complete one cycle, is now pi units rather than 2 pi units. Let's go ahead and change it up again. We'll change it to 3. All right, notice that by the time we get to 2 pi, we've gone through 1, 2, 3 complete cycles. Okay, so the length of one cycle is 2 pi over 3. If we change b to 4, it would be the length of a complete cycle, 2 pi over 4. In other words, pi over 2 units. You see that one complete cycle is done right there. Okay, so this multiplier out in front of the x, that is related to the length of one complete cycle. The bigger that number gets, the more compressed the cycle becomes. And let's watch what we do when we do this, 1 over b. Okay, I'm going to need to zoom out a little bit here. Okay, so right now b is 4. Let me go to 2. Okay, b is 1 over 2 now. So b is 2, we got 1 over 2x. Notice over here, one complete cycle now takes 4 pi units. Okay, so if this number is smaller than 1, it actually lengthens the cycle. If that number is bigger than 1, the cycle is compressed. Okay, so this multiplier is related to the period of the function. And remember, the period of a trig function is the distance it takes along the x-axis to go through one complete cycle. The ordinary period for the cosine function is 2 pi. If you put a 1/2 here, notice 4 pi. That's how far we have to go to complete a cycle. The same thing is true if we look at the sine function, let me change it up here. And we'll go to sine, let's just put sine b right there. B equals 1, we get the ordinary graph of the sine function. Starting at 0, up to 1, back down to 0, bottom out at -1, up to 0, one complete cycle in 2 pi units. If we change that multiplier to 2, look what happens. By 2 pi units, we've completed 2 full cycles. So one single cycle only took up to pi units. The period is pi. And if we do this, we can see we complete 3 cycles in 2 pi units. So one complete cycle in 2 pi over 3 units. The period is 2 pi over 3. If we change b to 4, the period is now pi over 2. Okay, so changing the multiplier in front of x affects the period of our trig function. Okay, let me go back and change b to 1, and I want to look at the tangent function. Okay, now you'll remember the tangent function actually has a different period. The tangent function has period pi, and it completes one full cycle between -pi over 2 and pi over 2. Let me adjust the settings on my window a little bit here. I want my x-axis to be -3.14 to 3.14. Okay, so kind of focusing on one complete cycle. My y-axis will be -10 to 10. And we'll make the step every 1 unit. Okay, so a little bit better picture of the tangent function here. Okay, so we've got the asymptotes for the tangent function here at pi over 2 and -pi over 2. And you'll notice this same exact picture repeats over and over again. So the period of the tangent function is pi. Let's look at what happens when we change b. Boop. Okay, notice we're getting 2 copies of that cycle. Okay, the period has been cut in half when we change that multiplier from 1 to 2. Okay, so the multiplier out in front of your x, that affects the period of your trig function. And the period, remember once again, that is the length of time it takes to complete one full cycle.